So now we're going to talk about a specific type of transformation called a translation. Please bear in mind translation and transformation are two different words. A translation is a type of transformation. That's what we're going to learn about right now. So a translation is literally moving a shape, moving a geometric shape, left or right, and up or down in any combination, okay? Now a vector translation. So a vector is, think of it like a directed line segment, or maybe a better way to think of that is an arrow, which has pointed in a certain direction and has a certain length, okay? So if I was to take a triangle like ABC and apply this translation to it, that is this vector, what I would be doing is taking each of these points that define this and moving them, which means B would move here to become B prime. A would move from here all the way here, so in that direction for that length, right, to become A prime, right? And here's where I didn't mark where B was, silly me, right? So B is actually right here, right? And then I do the same thing to C, and the reason I only need to do it to these 3 points is because they define, right, there's C prime, define this. Now if you look carefully, actually what's happening is every point is going to be, so if I'm tracing along this, I'm tracing along this side length here, right? So what it means is, if I were just to do this, the vertices, it's a lot simpler, less work, right? That is the new triangle. And this vector of translation, that is, I just moved this, in this case, to the right and a bit up, right? Now, does this preserve orientation? Well, if you take a look, this has an orientation of ACB, and this has an orientation of A prime, C prime, B prime, right? And the answer is yes, translations preserve orientation, right? Is it isometric or rigid? Well, if I take a look at this, I've just moved it over here. So yes, this is an isometry, that is, it's an isometric transformation from one to the other, okay? So that kind of takes care of some general classification. Now, I'm going to show you what the notation is. There's two different ways to go, right? We could say that xy becomes x plus a, y plus b. So xy would be our pre-image points, and this would be our image. Now specifically, this would mean we're using it a units left and right, and b units up and down, right? So this would indicate the left or right, and this would indicate the up or down. Now, how do we tell the difference between left and right, up or down? You might think, well, we'll take a look at some examples, but if you think of it, if A is positive, then it would be A plus a number. It would take the whatever the original X value is and move it in that direction. Now, if you think about it also, this means maybe if I'm moving it this way, A, and this way, B, the actual vector, it would be the straight line distance from beginning to end, right? This would be the vector of the translation. But we've broken it down then like a right triangle into the left and right and up and down pieces. Now the other way would be indicate T, and then A, B would be the amount in the X and the amount in the Y. If A is positive and B is positive, it would mean that X, Y, remember our original phantom point, whatever it may be, would become X plus A, Y plus B, right? If I had T, and let's say that was a negative 3 and 4, that would mean I take X, Y, and I take whatever the X, Y, these are numbers, right? I would add a negative 3 or subtract 3, and that would get me the result, the image, and I would take the Y and I'd add 4. So in general, for translations, we are adding or subtracting from the original, we'll call them pre-image, let's clean that up, pre-image points, right? From the pre-image points. Adding or subtracting would cause a different thing, left or right or up or down. So let's take a look at some examples. Okay. So let's say we had this triangle, right? And let's actually give this triangle some labels that might actually help. So let's go ahead and label this bad boy. Call this, look at it, it's going to be triangle ABC, I'm suspecting. A, B, and C. Now, when I do a transformation on this, it will only let me do it in terms of a vector. So let's go from this point to this point, right? And then I want to apply that to this. So what happened? Well, if I look specifically at what's going on here, I've got this. So my vector was from here to here, which would be 2 units, right? 2 units, 1, 2, 2 units just in the x direction. So in general, what I've done is I've done a t of 2, 0 on x, y, which would cause me to go to, let's make this a little narrower, x plus 2, y plus 0 I wouldn't bother with, I just write y. So for instance, if I'm looking at the point C, because this would be C prime, C would be 1, 2, 3, 4, 4, 2. What is C prime? 6, 2. That is, the y value has not changed, but the x value has changed, right? So let's take a look at another example. What if I want to do a translation, and I want to select a translation, choose, let's say from this point to, let's go with this point, right? And I'm going to apply it to this object. Okay, so let's take a look. What this means is I've gone from here to here, which would be down 3 and back 2, right? Similar to a slope, isn't it, right? So we'd say that this is a t, well, it's -2 in the x and -3 on the y, right? And if we did that to x, y, that would mean each point would become x minus 2, y minus 3, right? So let's label this up, a prime, b prime, c prime. Well, what is the coordinate for a? That looks to be 3, 4, and this would be 5, 4, and of course this was already 4, 2. So now if we label, let's see if we can actually do this, say that right there, right? That would mean c prime. Well, let's just predict. 3, 4, I should subtract 2 from the x, so that should be 1, right? And I should subtract 3, so 1, 1. And sure enough, you look, it is the point 1, 1. Here I subtract 2, so this should be 3, right? That's what b prime is going to be. And I subtract 3, this should be 1. 4, 2, what do I do with 4, 2? Well, drop that 2 and drop this 3, so it becomes -1, okay? So that's simply put what a translation would become, it adds or subtracts to the coordinates. If you're adding to the x, it's going to move it, so this is going to be plus x is going to move it to the right, and then subtracting from the x is going to move it to the left. Adding to the y is going to move it up, and logically subtracting from the y is going to move it down. That's how those work. And this would be the general notation. That's translations.